video we're going to be looking at endo and exothermic reactions, the two types of reactions that you need to know about for EDEXCEL Additional Chemistry Topic 5. Now, let's start off with exothermic reactions. Okay, think about this word. Exo means on the outside, thermic means heat. Exothermic reactions are reactions that release heat. So if I were to imagine I had just a closed system, this could be in a beaker or a cup, or it could be a room, it doesn't matter at all. And in the centre of that I've got my chemical, whatever it is that's reacting. In an exothermic reaction, when this chemical reacts, it is going to be releasing or giving out heat energy. So the heat energy is going to be released from the chemical energy stored in the system. Therefore, if you were to measure the temperature of the system, okay, so say you had a thermometer, here, that thermometer would go higher. The temperature of this whole system would increase because the chemicals have released or given out heat energy. Now, in an endothermic reaction, it is the exact opposite. Endothermic. These are reactions in which the chemicals take in heat energy over the course of the reaction. So, same idea again. If I had my exact same system, but this time I had a chemical that was doing an endothermic reaction. This might be something like potassium nitrate. Often when you dissolve salts in water, they do take in heat energy, they do endothermic reactions. Okay, so this time I've got my chemical which is going to do an endothermic reaction, and this time it is going to be taking in heat energy from the surroundings. So over the course of this reaction, heat energy is taken in. If you were to measure the amount of energy left in the system using a thermometer, it would look like the temperature the temperature would decrease. Okay, so in an exothermic reaction, overall the reaction is releasing heat energy, therefore the temperature of the system will increase. Endothermic reactions taking in heat energy, therefore the temperature of the system will decrease. And to look at this in a bit more detail, we are going to look at a reaction, and it's going to be the combustion of hydrogen in oxygen to form water. So first off, we need to balance this. We need a 2 there and a 2 here. Okay. In this reaction, there are two factors at play which determine whether the reaction is endothermic or exothermic, and it is all to do with how with bond making and bond breaking. So, in this reaction, then I'm starting off with 2 molecules of hydrogen. Okay, and I'm just going to represent the hydrogen here as hydrogen atoms with a single line or single bond in between them. Oxygen, it actually has a double bond. Okay, but it's just got a chemical bond between it. In H2O or water, I've got oxygen, hydrogen, hydrogen, and I've got another lot of it here, like so. Okay, so in order to get this reaction going, okay, in order to initiate or get the reaction started, I actually have to break all of these bonds here. Okay, so in the middle of this process here, I'm actually going to have hydrogen atoms that are loose flying around. So I'm going to have 4 of them. So I'll have broken both of these bonds, and I will have oxygen atoms that are loose flying around. In order to do that, in order to go from what I have here to having loose atoms like there, I have to put in a lot of energy. Okay, so I need to put energy in to break these bonds. Okay, so energy is needed to break bonds. So this is why if you have hydrogen or have most fuels, they will not explode spontaneously. You actually need to put a spark or a match or something to initiate or get the reaction going. And what that is doing is providing the energy to break or overcome these bonds, and the atoms can then rearrange to form your products. Okay, so to start the reaction off, I need to put energy in to break the bonds. At the end here, I've got two molecules again. My atoms have reformed bonds. So during this reaction, these atoms have rearranged themselves into this format and they've made new bonds. And that actually gives out energy. So energy is given out, energy released when bonds made. So overall then, the thing that determines whether a reaction is exothermic, releases heat, or endothermic, takes in heat, is simply the balance of these two factors. If when I make my bonds at the end, I get a lot of energy that is released, and it is much more than the energy needed to break the bonds in the first place, then overall my reaction will be exothermic. So in this case here, I need a little bit of energy to break these bonds in the first place to get to this stage. I get a lot more energy that's given out when these bonds are made, therefore the reaction is exothermic. In an endothermic reaction, it takes much more energy to break the bonds than is kind of given back or released when the bonds are made. So an endothermic reaction, you need to put more energy in to break the bonds than is released when you make new bonds. I actually think this is easier to understand using graphs. You do need to know the graphs for understand the graphs for higher tier. You don't for foundation, but I think it is useful to know anyway. Okay, so let's stick with this example we've got here. I'm going to leave this down here. Can we see that? Just about. Okay, and we're going to have a look at what this would look like graphically. So if I was going to show this using graphs, okay, along the side here, I'm going to have energy. And this is the amount of energy in that chemical. Okay, so at the start, I've got the energy that's, so I have my my atoms, which are bonded together in molecules. They have a certain amount of energy. Let's put that here. In order to get to this stage here, I have to put energy in order to break all those bonds. So I am going to increase the energy in my system, and that will get me up to this point here, this intermediate point. At the end, in this case, with this combustion reaction, I have a lot of energy that is given out when I make these bonds. Therefore, the energy of my product is going to be much lower. Let's say that is down here. So I need to put in this amount of energy to break those bonds in the first place. This here is the energy that is given out when I make my bonds for my products. The energy difference here, the gap from here to here, would be the energy released in the reaction. So E released in reaction. Okay, so let's label these up as well. This is showing your bond breaking. And this arrow here, the difference between right from the top and then at the bottom would be bond making. And this would be an example of an exothermic reaction. Exothermic. However, in an endothermic reaction, the idea is similar. To start with, we have got our energy. Okay, so we have our starter materials here. Okay, so let's say in this case, we are going to put a lot of energy in to get the reaction going. However, the energy released when our products form is only small. So the products are higher in energy than our starting materials. The graph would look like this. Okay, so this here is still bond breaking. This is still bond making. However, this time, our gap is the energy required. Oh, sorry, the energy taken in. during the reaction. And that is an endothermic reaction.